In this module, we will study the concept of factorial notation. The language of mathematics primarily comprises of numbers and symbols. Symbols, such as the ones shown, are used to compare numbers. Symbols are also used to represent mathematical operations performed on numbers. Consider the given expression. It involves repeated addition of a number, and the same can be expressed in a compact manner using a multiplication sign. Thus, symbols help us in presenting a mathematical idea in a compact and precise way. Consider that we have to find the sum of the first 100 natural numbers. Before we can calculate the value, we need to express the statement in terms of numbers and symbols. The statement can be mathematically represented as shown. However, the same expression can be expressed in a more compact way using the sigma notation as shown. The sigma notation thus helps us in representing a sum of numbers which are in a sequence in a compact manner. Now consider that we have to find the product of the first 100 natural numbers. The statement can be mathematically represented as shown. However, there exists a compact way of representing this product as shown. The exclamation symbol used is referred to as factorial, and the notation is known as factorial notation. The value thus obtained is read as 100 factorial. In general, n factorial represents the product of first n natural numbers. The value of n factorial can also be interpreted as the product of all natural numbers from n down to 1. We can see from the examples shown that the value of the factorial increases rapidly. We can also observe that each factorial can be expressed as a multiple of the previous factorial. We can see that 5 factorial can be expressed as the product of 4 factorial and 5. Similarly, 6 factorial can be expressed as a product of 5 factorial and 6. This gives us a recursive definition for the factorial of a number, as shown. Before we proceed further, we should note that by convention, the value of 0 factorial is assumed to be 1. Now consider the given expressions involving factorials. Calculate and enter the corresponding values in the result column. Click Submit when you are done. These calculations show us that a factorial plus b factorial is not necessarily same as a plus b factorial. Similar is the case with the other operations. Hence, we should always consider the product represented by the factorial before we carry out any such operation. We have seen that the product of first 10 natural numbers can be expressed as 10 factorial. Now look at the given pattern representing a product. Just as in the case of 10 factorial, it starts at 10 but does not go all the way up to 1. Can we express the value of such type of products using factorial notation? Let's see. Consider the expression for 10 factorial. On dividing both sides by the product of the first 6 natural numbers, we get the value of the given product as 10 factorial upon 6 factorial. If we were to further divide by the number 7 on both sides, we get the value of the product of 10, 9 and 8 in terms of factorial. In a similar manner, we can represent the product of 10 and 9 in terms of factorial. In general, this result can be formulated as shown. Let us now use this result to express the given product in terms of factorials. In this case, n is 20, and since the product involves 5 terms, r is 5. Let us now check whether you are up to this quiz. From the given options, select the value which is equal to 8 factorial upon 4 factorial. Eight factorial can be expressed as a multiple of 4 factorial as shown. We can now cancel out 4 factorial to get the value of the expression as 1680. From the given options, select the value which is equal to n plus 3 factorial upon n plus 1 factorial. N plus 3 factorial can be expressed as a multiple of n plus 1 factorial as shown. We can now cancel out n plus 1 factorial to get the value of the expression as n square plus 5n plus 6. From the given options, select the value which gives the same value as 12 factorial minus 10 factorial. Twelve factorial can be expressed as multiple 10 factorial as shown. On simplification, we get the result as shown. Which of the following gives the units place of n? Consider the given table. It can be seen that the units place of all factorial starting from 5 is equal to 0. This is because 5 factorial has 5 and 2 as factors, which makes it end with a 0. And since factorials starting from 6 to 100 factorial also satisfy this property, all of them end with 0. Thus, the units place of the given sum can be obtained by adding units places of factorials up to 4. This gives us a result of 3. Let us now summarize what we have learnt in this module. We have seen the product of the first n natural numbers can be expressed in terms of a factorial. Further, we have seen the recursive nature of a factorial. Also, we have seen some properties which are in general true for operations involving factorials.